So, hello and welcome to episode 11 of our STEM speaker series. Today we have two guests. We have Mr. Blanchette, who you all know from campus, and our very special guest, longtime acquaintance of Mr. Blanchette, Mr. Donald Lopez.
Thank you for the wonderful introduction.
Yeah, this is episode 11, so I'm getting better at it. Yeah.
There we go. Yeah.
So,
and I like it. This one goes to 11 for any Spinal Tap fans out there.
Yeah. Yeah, exactly. There you go. So thanks for joining us, Donald. Maybe you could briefly tell us about what you do.
Absolutely. Okay. So I work in the aerospace industry. I started off as a mechanical engineer. I started off doing design work, which is very much a part of mechanical engineering. Did a lot of 3D modeling, CATIA, drafting, whatever was needed for the design of cabin interiors. So specifically, we worked on the inside of the aircraft. Anything you see on the inside that you use, the lavatory where they prepare food, the galleys, the overhead bins, the seats, the sidewalls, any of that part, that's what our company does. So when I first joined, it was called C&D Zodiac. They were a much smaller company, got bought out by a big company called Zodiac Aerospace, based out of France. Basically, all of their businesses did very similar things, slightly different aspects of the cabin interior, but they all led to the same function or the same, really trying to accomplish the same thing. So, for example, the water and waste system, the electrical systems, the air duct systems, all of those were done by the Zodiac Aerospace company. Now we're called Safran Aerospace, and we're a much bigger company, about 90,000 employees.
Wow.
So that merger finished, I think was completed sometime in 2018. So there's been time to kind of come into the fold, and it's actually been a really good merger with this much bigger, or having this much bigger company now. But they also, their focus was not on cabin interiors at all, and they have other businesses that do landing gear, engines, all the other parts of the aircraft. They're getting really close to being able to build their own aircraft. We're not going to do that, of course, but my focus was on cabin interiors. Again, started off as design engineer, and then I moved into project engineering maybe 3 or 4 years after some mechanical experience. And there, the majority of my work was managing resources, making sure that we were adhering to schedules. Customer interface was the most important aspect of it, requirements management, technical overview of our design and the product that we give to the customer, as well as meetings with their own customer, which our primary customer was Bombardier, also Airbus, Boeing, et cetera, the large OEMs, original aircraft or engine manufacturer. But their customer are the airlines, of course, so Delta, Korean Airlines, Swiss Airlines, Southwest, whichever, basically any major airline ends up being one of their customers as well. So a lot of my function was making sure that when we were meeting with the customer, that we were signing ourselves up for requirements that we could meet and designs that we can accomplish. So sometimes we had to push the boundaries, which was of course good, but it also posed its own challenges in terms of schedule and cost, and sometimes weight as well, which are of course absolutely important in the aerospace field.
Sure.
So that I did that for, I believe, another 6 years. So I've been at that company almost 12 years now.
Wow.
I think it's 11 and a half. My new role is as a systems integrator. So similar functions, a lot of the same technical requirements management, integrating the different facilities that we have. So we are a multi-site team. We have about 6 different sites that are working together to build this cabin interior for our new customer. So that's really where I come in and making sure and bringing everything together, making sure we're following our requirements, and have some cohesion, I think is probably the best word to describe what my function is as a senior integrator for the Mitsubishi aircraft that we're designing.
Obviously, the last couple months, less travel, less flights. Has there been a trickle down into your company? Because obviously the airlines are changing, and then how's that come down?
Yeah, so unfortunately, we have been one of the industries that's been hit the hardest by this situation, especially with travel being down. It's difficult for airlines they already operate at very tight margins as it is. I know it's expensive to travel, but they have their reasons, of course. And without that revenue coming in, they're unable to pay their customer, which is the OEM, and in turn, the OEM then struggles to pay us as well. So unfortunately, we have been hit pretty hard, and unfortunately, a lot of the industry has been seeing a lot of layoffs as well, and furloughs. The furloughs, at least, there's people are going to get their job back, but with the layoffs, unfortunately, it's just we're losing a lot of talent, unfortunately, because they have to make hard decisions. So we've been hit kind of hard, but we've managed. For myself, I've been able to work from home no problem. It took a little bit of setup to make sure I had something ergonomic and a good working station. It becomes a little harder for a lot of other engineers because they have to access our internal systems. And when you have a 3D model that includes 2,000 components in it, becomes very difficult to do that from home, doing it over a virtual private network, a VPN. For me, because it's a lot of just documents, it becomes a little easier. But we're all doing what we can from home, and luckily, because it's so early in at least my current project, we're able to work from home with minimal effort. I don't want to say zero problem. We have our issues every so often, but it's manageable. And our customers doing the same, and so is our management team. And then essential effort like production, manufacturing, they're in the offices still, but we have to build a product. We have to be able to support the aircrafts that are out in service still, which there are still some airlines operating at maybe I think 5% capacity, but it's still we still need to be able to support them and ensure that they can continue to operate.
Yeah. Okay. So you kind of give us your long history, 11 and a half years of the company. Was math, science, STEM, all that stuff, was that an early interest of yours?
Yes. So I actually didn't know when I was really young what an engineer did. But one of the things that came up was I always liked math. And I think math is a very universal language. I grew up with Spanish as my first language. So especially coming here, I think I was 8 years old. I didn't speak a single word of English. And so math was that language that I can use without really having to study a new language per se.
Sure.
Obviously, there's always more to learn in math. But and of course, I struggled a little bit with that transition going from all Spanish to really picking up English. So it took me a little bit, right? But math was always that consistent part of my life. And I was pretty good at it, and I liked it. So one of the questions I posed my family and my parents, it was, what can I do with math if I want to go into a career with math? And having some family members so I'm from Nicaragua, some family members who were engineers, the answer my parents gave me, of course, was, oh, you could do engineering. So even at a young age, at the age of about 8 or 9, I knew I wanted to be an engineer, even if I didn't know what it actually did.
Yeah.
I didn't really even know until I got to college that I really found out what an engineer did. But
yeah.
I mean, of course, I don't regret that for a second. Engineer was definitely the calling for me, and I think for anybody who has any interest in math or science, it really is a good path. Not to say that the other STEM groups are, of course, science, math, any one of those, but engineering, of course, is another one where you can apply a lot of that. So.
Sure.
Yeah, I was going to throw in about college. Obviously, I know Donald from like third grade days, I think it was, right? Elementary school. And then it's kind of when, obviously, we all kind of split up our little crew from high school and kind of went our separate ways for college. And I know you went to UC Santa Barbara. So if you can like kind of tell like maybe the experience of kind of like what the program, the engineering program entailed there. And then also kind of maybe how once you got into the profession, how that was maybe different than what you anticipated coming out of college.
Oh, absolutely. And so it's a good question. So within Santa Barbara, and I know there's other schools that are similar, but I definitely think that the engineering programs can differ from school to school. So, but at least with my experience, it was very much a a very social engineering experience. I think that's something, at least that Santa Barbara has, that not every other engineering school would have. I'm not over here to sell UC Santa Barbara. I don't work for Santa Barbara, but I'm kind of doing that. No, but I think that was one of the experiences that I think was very important for me, in seeing that it's engineering functions and jobs require a lot of social interaction with other people, other experiences, other functions, because even within our company, if you're a mechanical engineer, you could go into flammability, you can go into certification, into stress engineering, you could do design. So any one of those is available to you as a mechanical engineer. And if you focus on one of those, you still have to interact with the others. So I think that was one of the key experiences that I really saw helped a lot to mold my career, was that social interaction. It was a huge emphasis on that within our program. And it really does help when you start your career and you're working with other people. We had a lot of group projects of 4 or 5 of us that we had to work together for an entire year to get a project out. And that's the case at a lot of schools, which I think is very important, is learning how to work with others, learning how to communicate effectively and efficiently. And so all of those become very important when you're going through school. And even if you don't know what industry you'll end up going into, those facets really exist in almost every single engineering career that somebody could take, or even a lot of the STEM jobs. Any one of those, your career will ask you to work with other people and to communicate effectively. It becomes very important. As far as to answer your question about career and my expectations, or in my experience, it's really one thing I learned is that going through school for STEM is that you're really learning how to solve problems. When you get to work, it's kind of like starting over again. There's a lot of knowledge that you've gained throughout obviously your schooling and through education, but ultimately some of those problems that that we're being taught to solve in school are really solved already by the time you get to a job. Sure. So really the key thing becomes being able to solve the problems that aren't exactly laid out for you in front of you for whatever project that you're working on. And that's not to say that there isn't going to be an opportunity to solve new problems and develop new things. But that's really what they're trying to teach you. And that's one of the things that really stuck out to me, is our ability to solve the problem. You may not have the answers with you when you get to work. So you're having to learn a lot of new things. And not just that, but companies, they all function a little bit differently. Of course, certain industries are driven by certain regulatory groups like FAA for us, or EASA. But then you also have the civil engineers of whatever state you're in also have certain processes and certain things on how they function. But they don't really lay those out in such a fashion to where they're basically handing you these answers or the way to work. So each company is really going to do that differently. So being able to solve problems and just being able to work those out with other people, knowing who to ask, becomes really important when you get to your job or to an industry.
Yeah. So Matt and I teach math, and we've encountered I'm speaking for you, Matt, but I assume you have the same situation, but we encounter many students who might have to solve a problem and they get it wrong on their first try and they want to give up. Now, what does that look like in real life? How often are you guys getting stuck on the first try? And if you don't, what's it look like afterwards?
Even with all of the tools and analysis that we have available to us, there are still things that go wrong. So as a project engineer, I had to plan contingencies, and I had to always have a backup, or at least something that would support my schedule for if we failed. So it happens. The thing is learning from that mistake and trying to avoid that in the future. Yeah. And that becomes actually a really big thing, especially when a company like mine, and I'm not trying to to make it seem like they do all these things wrong, but there have been instances where we've committed an error on one product and that same error shows up on a new product. And that's because there's that collaboration wasn't there. That tracking and that learning from the mistakes that somebody else already made. But it happens. And so really the key thing is being able to prevent those mistakes from happening in the future, having good documentation and good communication with everybody else who's doing something similar. But yeah, mistakes happen quite often, a little more often than they should. Good thing is that at least in the aerospace industry, all these acts or any of these errors or failures happen during our testing. So there is a lot of testing that needs to happen, and that's how we validate and verify that our designs, that our calculations, whatever it is that we need to do, is correct. Because doing it on paper, yeah, it may not, it may look right until you actually test it. Some things are just too complex to really fully rely on a calculation, because it's a little more complicated than just 1 + 2, right? It's sometimes a design that isn't a simple beam or isn't a simple geometrical shape. Then we have to test it, and we have to rely on our actual real life testing as opposed to just analysis. But yeah, things fail. It's not the end of the world when they do. You may just have to crunch for it. That's it.
Yeah, I like the phrase "failing forward."
There you go. Yeah, I like that.
Yeah,
I think when you're kind of talking about the calculations and this aerospace level crunching of numbers and things like that, just curious, what kind of like math are we talking about that you do use on a regular basis, whether it's your specific role or perhaps like the general kind of what goes into some of that math work in the industry? I mean, the age-old question, I'm sure that we get, math teachers is, when am I going to use this in real life? Or like, it's kind of, it's to see it applied, like how do you actually incorporate it
absolutely.
Every day?
Yeah, so what's funny is that sometimes I'm going to have to think about this, only because sometimes you're doing the math without really thinking about what math am I using. But no, but definitely algebra. So even in things that I did as a project engineer, when I was no longer having to do true like engineering calculations, I was still having to use algebra to find, for example, the area under of a curve, to calculate things like resources and forecasts. You still have to use calculus. Sorry, it's not even algebra, it's calculus at that point. So calculus easily comes in there when we're talking about things like stress and strain. Oh, that's heavy into calculus, already into applied mathematics at that point. So we're easily seeing things like algebra all the time. Even within Excel, it becomes a necessity to use all of those basics that we use. And of course, geometry all the time, because we're dealing with design here. So geometry becomes a huge factor in that. Sometimes it sounds simple when we talk about a door opening on a lavatory, but we've had instances where if somebody didn't do the calculation, your door is now calculating or clashing with something or hitting something that it shouldn't, or overextending because you have a deflection, because then you have to consider the material properties of your product or of your door. So we see it in all facets. So even in my job, where I'm not even doing true engineering anymore, I'm still having to use calculus and algebra constantly.
Well, there you go, boys and girls. Math is applicable to future careers. So
yes,
there you go.
Algebra is even useful if you're trying to split your bill with your roommate. I mean,
absolutely.
Yeah, man.
or budgeting in general, right?
Yes, exactly.
Yeah. So do you have any advice that you could offer students that are interested in engineering in general, or getting into aerospace, anything like that?
Yeah, absolutely. Well, one, it's school. So schools, this one's like a random one, but learn Excel. I had very little experience with Excel when I was in college, because I found MATLAB a lot more useful and a lot more powerful. But MATLAB licenses aren't available everywhere, so definitely learn Excel. That one's just a freebie. But in general, I definitely think that it's very helpful to have several internships while in school, really to gauge what you want to do. There may be a certain industry or certain field that a student may want to enter, but really being able to see it in person themselves, having an internship within a company, that experience, just you really can't put a value on that, and it's really hard to gain that experience without actually being there, and that really will help anybody make a more informed decision on what industry they end up entering after college. In all honesty, you probably can't go too wrong on whatever industry you go. Some companies, okay, it may not be the ideal situation, but there's also a lot of really good companies to go work for. But I think seeing that and having an internship within that's really where it becomes helpful. Even if it's a free one, as long as they don't have you doing busy work, that's unpaid internship. You can't do that.
Yeah.
Just know that as well. But even a free internship, as long as you're learning, then it pays for itself. That experience is invaluable.
No, man, just, proud of you. It's good to, it's good to see you excelling in the world, started from the bottom, now we're here, right? So
yeah. Exactly.
All right. Well, that's a wrap, ladies and gentlemen. Thank you very much for Donald Lopez for joining us today, episode 11. Watch it in its entirety.
You the man.